Good afternoon, everyone. Now we start our track 3 last session of the day. Topic is Downstream Ground Network in Hybrid Space Architecture. And now I request our session chairperson and moderator, Mr. A.K. Anil Kumar, who is the Associate Director, ISTRAC ISRO. Please, sir, join the dais and start the session. Thank you.
Good afternoon. Thank you for the invitation to this Indian Space Congress. This is a session. We have 6 speakers. Let me invite them to come to the stage. Dr. R.K. Singh, Managing Director, Satcom, please. Mr. John Saripally, Mr. Srinath, Logasubramanian, Sri J. Daniel, Mr. Vinod Kaul, Mr. Manoj Dhaka. Once more, good afternoon. We have about up to 4 o'clock, 80 minutes time. We have 6 speakers. I am not speaking at all. So, this panel type of discussion, what we will do is, we will maybe 5 minutes each we will give to people to briefly tell their activities and their plans. Then we will come back to the audience also. 1 or 2, 3 rounds we will go in among the panelists, and the questions answer will be from the audience also. We will be doing it. To start with, as such, if you see in the introduction to the downstream ground network in hybrid space architecture, the organizers themselves have put forward some good points. So they said space and ground systems need to work hand in hand, and both constitute essential parts that need to be addressed when striving for optimized efficiency. Yes, that is very important thing, because what we found is mostly when the space industry is coming up, and especially in India, it is open to private industries. Space field itself is open. Then mostly people will look into 2 areas, launch vehicle and satellite. And mostly one forgotten area is the ground network, which is of so much importance. As we see any product from the final product from the space comes through the simulations, through the analysis of the data and the deliverables from the data only. All these things should come through the ground stations only. Ground stations and the associated the software, they are very important. But mostly people look into that aspects when they come already. Satellite is ready, they want to launch, then they will think about what to do now. Then they have to search for the people supporting the data transmission, telemetry, tracking, all those things. And industry-wise also, industry is putting a lot of money in launch vehicles as well as satellites. Yes, huge investment is required for the ground stations if you want to make the facility, etc. But people have to think about this. That is one important aspect of discussion. I think many people, our people will be discussing about that. And so cost-effective space missions or space operations requires quality ground station network. So let us start the discussions one by one. I will first we have a keynote address by Dr. R.K. So let me invite him.
Thank you. Thank you, SAI, for bringing all of us together. And as Mr. Anil said just now, that ground station people sometimes feel that this is the least or very easy systems where you just need to pull up the antenna and start working, and the rest all are more important. It's like everything is important in the ecosystem. And I'd like to just take you to the antenna portion, what we have been doing it, especially ground network in a hybrid architecture. So my take is on a hybrid network. If you see the geo backbone, geo satellites are mainly, as of now, used for backbone, terrestrial, or a private network or a core network. However, you can complement MEO and LEO as a system which can be used for public internet. So as of now, you find all those LEO, MEO satellites on a commercial sector, mainly launched for internet connectivity. If we move on to let you know that how hybrid network will help this architecture, how it's demonstrated a network architecture that leverage both commercial and government assets, space assets, which can diverse orbits to provide secure, assured, and very low latency data communication. So I understand that each orbit has a separate positives and separate negatives. Like GEO has a long latency, but then you have more throughput and easy to cover and less commercial requirement. However, if you go towards LEO and MEO, you have more more funds required, but of course low latency and other application can be done. These are some of the pictures of what we have been doing in CPI. We have good amount of LEO products which we manufactures and already in the market. The main thing here is the speed of the tracking system. So the tracking system which we deploy, and also the pedestal on it plays a key role how the system is going to work on a LEO or MEO orbit. So we have system which starts from 1.8 meter, goes up to the 6 meters with all the tracking speed of 10 meter per second up to 25 meter per second also. As we move on LEO tracking terminal markets, mainly we categorize LEO as 3 different markets. One is the Earth resource satellite, which is imaginary and sensor application, and the bands which you find as S and X band originally, but other frequency bands are also coming in. So we have systems already in place for all these frequencies. Next specific is classified and scientific. So when we say classified and scientific networks are basically for the purpose of monitoring and all those. And of course, the talk of the day, and recently we congratulate ISRO to launch the OneWeb satellite, which is a LEO constellation. So O3b and OneWeb, all these guys are into this segment. Earth resource satellite markets, which is like orbital system antenna, are significantly in this market for whether it's a weather or imaginary or Earth sensor missions or a government scientific. Here again, I'll not repeat, it's S and X band is very common, but now we have seen increase of demand towards K band, higher data rates. The market is evolving. Most of the systems are already, ground stations are already in place. The classified scientific market is supporting LEO launch. So when you see this 18 meter and larger antennas, full motion antennas in place from CPI, they help LEO satellite launch by targeting and keeping that satellites in the orbit. Emerging big LEO markets. So if we talk about big LEO constellations, we'll have thousands of satellites up running in future. Of course, in this segment, you have to reduce the size of the antenna and also move towards phased array user terminals. If you talk about OneWeb, K users, K gateways, plant systems and K band, but many companies we have seen that they are moving, they're also demanding or signing an application on QV band. So this is the shift which is happening. So it's like a lot of development, a lot of new upcoming things are coming in terms of the terminal development. So we initially thought of C band, KU band, moves towards K, now QV, and this is a new latest development which is happening. If we talk about HTS, very high throughput satellites, gateway antennas, much systems needed, KQV is a new thing which is happening, most development. We have systems which is already start from 7 meter up to 9.2 meter for the QV band already installed and running. So we expect that there will be a lot of new requirement on a geo satellite. So geo orbit is not going to die, as we just discussed before. And there will be a lot of more development in terms of the frequencies, antennas, and that's what you can see that QV band is coming up. There's a lot of work happening on turning head antennas, full motion antennas, especially for the lunar mission deep space. So the first antenna here is like, if you see, it's in ISRO Bangalore, and this has been used under Chandrayaan 1 and Chandrayaan 2. And a lot of work on lunar missions for India and abroad. We have been involved, and we are making antennas start from 9 meter up to 30 meter. In fact, there are Galileo program where we do 100 meter array antennas. LEO and MEO launch support. So these are the antennas which are used for LEO and MEO support launch. There's a photograph from ESA. And even if you are exploring LEO launch, don't feel that the antenna which are already there, existing antenna for a bigger full motion antenna, it'll definitely be used for LEO launch. This is one of the new antenna which we are developing for the tracking terminal market. So it's basically for object tracking. So you can say UAV tracking. So this has a different usage. In military, it's a UAV tracking. In commercial, mostly like, you know, frequency international government or scanning and all those things. For LEO, what we are trying to do is that now to avoid space debris and all those things, we can track and give the command confirmation and all the data to back to LEO satellites to avoid collision. So these are the things. This is one of the antenna which we feel that will be a stopgap till we solve the problem of space debris. This antenna, you've already seen it. Basically, man-pack antennas which are used in geo orbit. The fixed models start from 0.6 meter to 2.4 meter. They're deployed on various applications, mainly for disaster management or a government business or anything. This gives a fair idea that what kind of different development an antenna manufacturer person has to do it for a different orbits. So we are already there for many years in doing a development on LEO and MEO and GEO. So this is a short presentation. I thought I'll give you a fair idea. Thanks.
Yeah, thank you, R.K. Singh. A brief presentation on the capability and what are demonstrated in elsewhere. Any questions on keynote address? Later we'll come back. Yeah, just I want to ask you one question only. This when you talk about stopgap arrangement for space debris problem, there are a lot of other issues related to the latency of the downlinking, analysis in the ground, comparing the, if you want to do a maneuver in the satellite, again doing another maneuver in satellite requires a lot of analysis with considering other objects, other collision risk is there. So whether is it possible with this one, with the present system, or we have to plan for, or the industry itself has to plan for multi-object tracking radars, phased array things. Do you have anything?
Thank you, sir. This is basically will give you an idea about the object. So this is just to track an object and to give you an idea that some of the objects are nearby. But rest all, you have to analyze these data and then take it from there to either LEO satellites or MEO, and it's not going to remove your debris, but just give you an idea about that.
Okay, let us go to the panels on their. So we'll come back from left or right. Okay. Yeah, sir, Manoj, Dhaka.
Good afternoon. I come from Defense Electronics Application Lab from DRDO, and I'm looking after the satellite communication and satellite-based surveillance, as well as SDR activities in DEAL. In this domain, we have been working based on the platform. Like, for example, there is a given satellite, which is done by ISRO, and the ground segment development is taken by us for our defense forces. Defense forces have a different kind of requirement. As you know, their communication has to be secure, end-to-end. That is one requirement, an interface to their gateways, their captive communication network. Those networks have to be connected. And of course, they would like to have as light as possible the ground segment so that it can be carried to the difficult terrain wherever they are operating. So those requirements are there, but primarily towards the communication aspect, we have been working. As you know, in between, except for one instance, most of our satellites are bent pipe transponders. So bent pipe transponders, there is not much you can do, reason being, especially because the satellite life is now coming to 15 years or more. Once it is, so basically what, with the changing technology, the requirement is to have some kind of software defined payload itself, because every 5 years, 6 years, technological jump is there. Things are changing, new waveforms are coming, new coding schemes are coming, new modulation schemes are coming. So we can't afford to have same transponder for 15, 16 or plus, those many years. So that is one requirement that as a designer for defense forces, we feel that that kind of transponder should be taken up. So this is one requirement. Of course, from defense perspective, we should have some, steerable beams so that wherever there is a hotspot, it should be steerable to that location. More resources dynamically can be allocated to those areas. There should be beam nulling features so that any jamming signal coming to the transponder, that also can be, handled by the satellite itself. So these are some of the, you can say some kind of wish list that we have from MOD side, what kind of transponders we should have. But today we are speaking about the hybrid, space architecture where there is a flurry of activity in the lower Earth orbits. So many solutions, so many excitement is there in the, in this particular domain. In fact, when we were thinking, that geostationary orbit is the only solution for communication, and LEO orbits will be basically for surveillance and radar and EO sensing and all those things. Our commercial sector was moving very fast. They were dreaming big, and the scale of thinking was huge. So I admit that as a government sector, we have not thought of those, at that scale as we should have, maybe. That is the reason why they are there and we are not. That's a good thing. That's a good thing to have. Now, having these satellites, in fact, huge number of satellites which are, coming into the orbit, from communication perspective, communication anywhere with a very, handy, lightweight communication equipment. That's a big boom. But as I was discussing with Kumar Saab from ISTRAC, that the more the number of satellites being launched in the orbit, nobody's thinking about the debris, how it will be handled in future. So that is another problem. That is another issue that will be coming up. So, so from this, hybrid space architecture point of view, the way we look at it, that we have to marry the new low Earth orbit network solutions which are coming from private sector with existing, the big birds rather, which are available in geo orbits or which are likely to come in geo orbit, because that will remain. As we know, the advantages of having a satellite in geo orbits. So how we can take advantage of both, from defense perspective. For that, we will like to have that the hub station for these constellations, which are some of them are from foreign-based companies. There must be some kind of guarantee that the traffic which is originated from defense users should remain within the country's boundaries. So some kind of, that kind of guarantee should be, ensured by the operators. And that we'll see how once we have discussions with them, how we can make use of that. Because defense segment is a big user segment, and definitely defense users will also like to exploit the existing technologies. As you know, it's not only the simple, end-to-end encryption. We also, have different kind of waveforms which we don't talk much about in public. For example, in peacetime, or you can have a different kind of waveform, but at the time of some kind of war or some, we'll have a different kind of waveform. Some anti-jam features will be there, and so on and so forth. In fact, one of the, having a bent pipe transponder, as a person, I feel that there is no need to have your own bent pipe transponder to use your anti-jam waveform. I mean, you can exploit foreign satellites also to have your communication without them knowing about it. So that is another way of looking at it. You may discuss with me this thing later on. It may sound unethical, but there are some realities. So that is one thing. So from defense perspective, this what I will also appeal our friend in ISRO, that in future this software-defined payloads, that is one area we have to focus on. And spectrum coordination is another area where we have suffered and we are suffering actually. In one of the frequency bands where we had a satellite, now many base stations are coming, terrestrial links are coming in the neighboring countries, and they are affecting our communication through the geostationary satellite. So that also at international level has to be coordinated in a very big way. Otherwise, we may have it, bird in the sky, but we may not be able to exploit it to the full extent. So that is another concern that I'd like to highlight here. So I think that is all from my side. And if any questions regarding that, we can discuss during the. Thank you.
Yeah, let us go to Mr. Vinod Kaul.
Hi, good afternoon, everyone. My name is Vinod. I am basically heading this Gilat satellite networks for the Asia region. Gilat is an Israeli company. We are manufacturers of the ground equipment, primarily focusing on baseband, modems, some specialized antennas, and RF equipment. So this is where we specialize in. Coming to the discussion today, well, there have been we've been listening from last 3 days on all the new satellites which are getting launched or launched, which is high throughput. The capacities have gone up. There is a software definition coming in the satellite industry where software-defined satellites are being launched, which Manoj also talks about a need for Indian defense forces. So all of it requires a different addressing of the ground segment and how the ground segment has evolved or is evolving to handle such kind of large requirements. So in Gilat we believe in something called as ground space harmony, where the ground equipment has to be truly elastic in nature. When we look at the way satellites are getting defined and getting launched, so the ground segment on the baseband side has to be really elastic in nature. And when we talk of there are few parameters where a lot of focus and a lot of changes are happening drastically on the ground segment. One of them is the efficiency factor. When you are launching gigabytes of capacity, how efficiently the ground segment is delivering them to the end user, to the application. So the bits to Hertz ratio, how much you are getting from the Hertz and how many bits you get from it, is something where a lot of focus is on the technology on the ground segment, which is developed. We are talking of 5 to 7 bits per Hertz today. And that's something where the new modulation techniques of 64 COM or 256 APSK, these kind of modulations are getting used on the satellite front. And you know, we have moved from very small capacity usages. Now the applications where satellite where the baseband has to be used is like you have an IoT kind of an application also, and you have a trunking application also. So the range is from today even with kbps to gbps. So the baseband which handles such kind of applications has really to be an elastic in nature to handle these kind of full kbps to gbps kind of applications. Another field where the basebands have evolved and changed is because of the software definition in the satellite, where the beam is there's no allocation of a beam or a bandwidth over an area. It's a moving beam. So there is an orchestration which is coming into picture, where the baseband has to understand, has to orchestrate with the satellite how to allocate the beam. And also there's a challenge that the traffic in some area could be high, the traffic in some area could be low. So how do you manage the capacity? The NMS which is getting developed or which is getting used by the baseband manufacturers is become much more advanced. And so that's another development which is happening on the baseband side. Another point which I wanted to highlight is that we talk about cloud architectures, we talk of virtualization. So if you see on the baseband side also, if the hardware is kind of out, you have softwareization of the hardware. So when I say that, it means that today all the baseband manufacturers are kind of using very high density hardwares which can be residing in a data center somewhere, or as we move ahead, it will be a cloud-based architecture where the baseband will be in a cloud. We still have the antenna and the RF, which will still have to be physically at some place looking at the satellite. So that there's not much of a change on that front, because antenna is really is a physical element which has to be there. But the baseband side, the changes happening is that it's all getting into virtualization, going into the cloud, where and it's all about software. And the hardware will be standard hardwares which a cloud operator would be using, and then this enables handling of multiple beams of these LEO, MEO, or GEO constellations. And it allows in handling GBPS capacities. And another point where a lot of developments are happening is the power side. Power and the space, is becoming a challenge in all these things. When you have a large constellation of satellites and you have to set up few tens of teleports to handle that satellite. Just to give an example, we are using IFC in-flight connectivity service with a service provider. We have 24 teleports across the globe, and it is along with Intelsat. We offer IFC services to around 3,000 plus aircrafts across the globe. So when you set up such number of teleports, the space of the data center, the power of the data center does need to have been addressed, and a lot of advancements are happening on that front, where energy efficient hardware is being built up to handle large capacities. And then lastly, about the hybrid architecture, which Manoj also talked about, the LEO, MEO, and GEO. How do they work in tandem together? So we recently did a testing with Telesat, which is a LEO satellite, along with a GEO satellite for a transatlantic flight. where the service in one area was LEO, and then as it moved into Europe, the service shifted to a geo satellite. So yes, the baseband technologies, where it is the baseband or electronic steerable antennas, which we also do for the aircrafts, are getting more and more better to handle such kind of hybrid architectures. These are some of the new developments which are happening on the ground systems. While the session goes on, we can talk more about this. Thank you.
Thank you, Mr. Vinod. And now we'll move to John.
Good evening to all of you. First, I thank SIA-INDIA organizing this India Space Congress, wherein we all could meet and deliberate on the issues pertaining to Satcom industry. I am with this industry for the last 50 years. That's why I want to start with a brief note on how it started, a brief on the emergence of ground station antennas. Basically, I am a manufacturer of antenna systems, right from almost, let's say, I am in this line for the last 50 years. That's why I can relate the old story, how we started. To be frank, you know, when it was started, lot of importance was given to antenna system. That time, even the Department of Space, they were even just starting the manufacture of the, the satellite, but they were all put to orbit by some other means and all that. From there, we have grown to this day, where the other day we could put 36 satellites in orbit. So that's a great journey, I can say. The same way, when we have started, even we had to take the designs of the antennas. The time this overseas communication organization, they wanted a 97 feet antenna. So that time, that is in 1968. Then ISRO, they have started one organization by name MASEC, that is Microwave Antenna Systems Engineering Group. But that time, that is an undivided Department of Atomic Energy and headed by Dr. Vikram Sarabhai. He has given so much of importance, and that's why the first antenna system was imported from Japan. It is a 45 feet antenna, and that was installed in Space Application Center, Ahmedabad. Actually, these are all the starting points where we could learn actually how to design the antennas and all that. So from there, today we have come to such a stage, we are actually manufacturing antennas. To be frank, you know, electronic side, even though we work with them, much of it I don't know anything. See, I know how to design an antenna. Today, even we have designed antennas, even for the LEO satellites. We have already given XY antennas, and we are ready with the gamut, even transportable antennas or anything. You say anything. Today, we are able to manufacture antennas, and we have grown to that level. All because initially, when the whole Department of Atomic Energy, that time, you know, in 1965 onwards, when the actual satellites were put on the orbit, the world's first commercial communication satellite services, they were started in 1965. So our founding fathers of this, government, and also supported by the government at the time, late Indira Gandhi was there, and she has given so much of leverage to the Department of Space, and that is how we could come to this level. I can proudly say that today Department of Space is one of the pioneering organizations which is if you ask me, of course, I can speak quite a lot about. I started my career in 1971 with ISRO in Massive. And the mechanical group, I belong to mechanical engineering, so we were shifted to ECIL. And the electronics group, our Kalla Saab, along with his group, they stayed back in ISRO. That is how it happened and all. But whatever it is, right from that day, that is from 1968, 70, 71 onwards, Space Application Center, Ahmedabad, they were very much involved in the design of the antenna system. And that time, they have integrated with ECIL, where I was there afterwards for almost 18 years. That is how, from that time onwards, we were, along with the Space Application Center or even ISRO, we have designed many antenna systems. Today, we also manufacture a lot of antenna systems to ISRO and to SI Directorate and the Defense and RD. Of course, along with our friends CPI, GD Satcom or AsiaSat and all those people. Anyway, today I can say that yes, we have grown to this level where we can go with the latest developments, even whatever antennas the Indian industry wants, probably we will be able to do it. In fact, recently we have even supplied our antennas to USA, and I'm very happy about it because, see, let us consider this. At one time, we were actually importing all the antennas here. Today, at least we have grown to a level where now we'll be able to supply antennas if somebody asks. In fact, we have received so many, inquiries about antennas from Germany, then, say, other European countries, even Southeast Asia and all that. Why I am telling? Probably antennas-wise, India, with the public sector companies, private sector like mine, and then GD Satcom, then CPI and all that, I think we should be able to do everything. There is no necessity for imports and all that. This is what I feel. But up to antenna with the control system, with the feeds and all that, up to that we can do. But anyway, the rest of the things we are already importing, like the uplink, downlink chains and all that, we are already importing. So why do you want to import antennas? Always I question this to the, government and others. Anyway, my friend should, should not think otherwise. So this is my humble, this one. Probably antennas and all that can be manufactured, even the LEO satellite. First, give the specification in for the Q or V satellites, which are going up to even 50, 55 gigahertz in the frequency. Yes, we'll work and see that the antennas are made to that. If the Indian industry, even for example, this, Airtel, they are thinking of going for this communications in LEO and all that. We can come forward and design the antennas to suit that one. It may be a little difficult initially, but whatever it is, maybe you give us some time, 1 year or whatever it is, I think we should be able to do it. And once again, thank you for giving me this opportunity. Okay, thanks and thank you.
Yeah. Thank you, John. And the clapping says what you said acceptable. Now let me call Srinath Logasubramanian.
Good afternoon. At first, I thank for the opportunity with SIA, and in the essence of time, I will give you a very brief introduction about Telespazio. Telespazio is a European largest teleport operator based out of Ticino, and we do have ground stations across Europe and South America. And we have a lot of knowledge in ground segment. What we are trying to do is how we can repurpose this knowledge for the new space economy. So we have started something called as a platform called ISRO, which is a ground station aggregator where we have partnered with LeaveSpace and other ground station providers. and provide autonomous ground station booking. And we also provide mission planning, mission control, and all other benefits. So there are a lot of technological advancements taking place in the ground segment, but it has to reach the right people at the right time, and it should be commercially viable for them. And this is what Telespazio is trying to make a difference and a change, trying to work at a much cost-effective solution for the new space industry. Happy to discuss further during the panel. Thank you.
Hey everyone, this is Dialani. I lead the US office for LeaveSpace. LeaveSpace is a ground segment as a service provider headquartered in Milan, Italy. We have been around for 8 years now, so technically still a startup. What we provide is we reduce the cost of access to space for satellite operators by operating a variety of ground stations around the world. So what we do is we buy antennas from companies such as CPI and Comsat and Comtech, Safran, different manufacturers. We plug in, the radio, baseband radio communication, and we operate it as a service. So we sell capacity to satellite operators so that they can get contacts, they can send commands to the satellite, they can downlink large amounts of data, be it Earth observation or other scientific missions. What our goal is to reduce the third leg of the stool, which is the ground segment. So what we have seen is a dramatic reduction in costs for satellite manufacturing, which is the first one, and the second one is the launch costs. But nobody's focused on, or very few people have been focused on ground segment, which is the third leg of the stool. And our mission is to bring that offering to the market and make it easier for even small startups which are still working from the garage to enable access to space. Thank you.
Thank you, Jay. One round of discussions are over. And just one thing, there is cost effective, low cost access to space, yes. It is not only launch vehicle or a satellite. Equally important the ground systems that I think almost people are getting realized that, but still it is not in the total mainstream. So this is one of the important thing. Latency of downlinking, huge data downlinking, faster how much it is required, Gbps and so on. So these are all challenges coming for these ground stations and back-end software coming, whatever coming it. Now it is open to public audience. You can ask questions, please.
Okay, sir, as this race heats up for towards more and more gigahertz for high data rate, how do we account for such a situation where we don't want lossy kind of reception? How, as the race is going more and more towards Q, V, all those bands, how is this concept of reliability being taken care of?
Yeah. Basically, as the ground, there are the three elements to this. One is the antenna. We look at the way the technologies have developed to handle fades, and this is exactly, I think, the question you're asking, that how the links become more stable when we move to higher frequencies and higher bit rates. So what has happened is over a period of time that the ground systems, particularly the baseband part, the antenna is kind of a fixed passive element. Then you have a radio, and then you have a baseband which is connected at the central NOC, and you have a CP or a modem at the remote. So the link is between the modem and between the two modems, and that's how. And so there are three elements to it. One is the link budget, which happens between the two sides, and then when we move to higher frequencies, if you see today, we have modulation techniques which have gone up. You have automatic power control systems where when the rain fades, automatically the power levels go up to cater to the rain fades. Then you have access mechanism, the way you access the capacity, the bandwidth from the system, the way it is accessed, that you have EB by NO ranges have gone from, they have become much more wider to handle any kind of range fades. We talk of even BPSK modulation and spread spectrum technologies to cater to such kind of links where the stability of the link is more important, the speed is not important, but at some places it is a speed which is of relevance and availability can be 99%. But if you need an availability of 99.9%, today's technologies on the baseband side cater to such kind of things by efficient modulation, demodulation techniques, the way the access mechanism, which is mainly TDMA, FTDMA based, are designed.
Great, thank you.
In 3 different areas. So one of the areas where the advancements are going on is in the antenna capability. So one person we are missing here is the phasor array antenna on the end user side. So you have phasor array antenna which can talk to LEO, GEO, MEO and whatever. And the other one on the baseband side, you have software defined radio where you can decide which frequency you are using for. And this is a question the industry faces every time. So when we moved away from C to KU, there was a lot of skepticism. From KU to KA, it's susceptible to rain and other such things. So as the technology grows and as the innovation happens, I think the way forward is Q and V only. So that's how we catch up with the market, and that's how we can grow and access the spectrum that is available. So the innovation is already in place. So there are a lot of companies innovating on the ground segment side, as I said, phasor arena, software defined radio, and also there are specific modulation. So when we started with a very low modulation. Now I think it's QPSK 64 or something. And you also have a lot of developments on the modem side with adaptive power, as Sir mentioned. We also have something called as adaptive code modulation, where the code, different frequencies at different situations, the code automatically adopts. So I think the industry is already ready to do that. And as we test, we learn, we fail, we learn, and we'll be into Q&A in a year's time. Hope I answered your words.
Yeah, to add to Vinod and Shree's comments, from our perspective, when we look at supporting higher frequencies for customers, you're absolutely right. The higher you go in frequency, the more susceptible you are to weather changes. The more moisture in the air, the weaker the signal gets. So we focus on deploying antennas in drier areas or drier regions of the globe. So for example, if I want to support KA, I would not install an antenna in Pondicherry. I would install it in Middle East somewhere. So those are some of the considerations that satellite operators also have to work in conjunction with the ground terminal providers or ground station service providers, so that they can plan appropriate communications and service levels for their own customers.
Yeah, apart from what Vinod and other team members said, that modem and modulation schemes and all those things, when you talk about QE band, a lot of research has been done on feed developments and control systems. So on the side of stability with respect to the bigger, larger antenna, that also a lot of mechanisms are also there. It doesn't look only the metal part, but also there are a lot of electronics inbuilt into the system, and of late we have multiple tracking systems, and all those stuff is also inbuilt.
Yeah, challenges are challenging requirements, lot of requirements, challenges will come, and contradictory requirements, challenges will come, innovations will follow. That is what idea. Question.
Yeah, my name is Prabhat. I work for Hughes. We are into access it through the cloud. Then more latency will be introduced because of the more end-to-end delay that is getting introduced because of the going into the cloud. So how do you see that as a challenge, and how you are solving it? And number 2 is, extension to his question.
Yeah, thank you. So basically, the first question regarding virtualization. Look, when you basically what we're doing is the baseband today is associated with the Earth station. Like you have an antenna RF and you have a baseband down there. So what we're moving is the baseband part we're moving to a data center. And well, there is a modulator which is at the RF which remains there. There's a data processing part which is basically the routing and other things which is moving to a data center. So this link to a data center to this Earth station is generally on a fiber link which adds a few milliseconds of delay to the whole link when you are talking of the complete end-to-end link between a remote station to the application side. So it's not much of a challenge because the fiber is available generally when you're on the terrestrial technology. So that's one part of it. And the second question was regarding the reliability. I think it was answered. We can have more answer from them. On the last question on the how much capability you have on the modems. Today the technology has developed. When you look at LEO systems, we work with few of them. We work with SES is another satellite operator on the MEO side. So we today are talking about 1 gigabit of gigabytes of download and GBPS kind of capability in the modems. And when you say assured how much you can get, it depends on the link budget and it depends on how much you want and how much you really seek. But the modem capabilities are going higher and higher, so there's no challenge on the modem capabilities.
But there must be some industries who are asking for a guaranteed SLA, right? So, I mean, for example, in 5G, it is the case that they want a slice of the network which guarantees a 1 millisecond of delay or a 10 Gbps of data or a 99.69 reliability. That kind of SLAs people are signing with the 5G operators. So,
okay.
Yeah.
On the 5G side, as Gilat, when I talk about, or generally on most of the baseband equipment manufacturers, we extensively work with most of the operators in India as well as in other parts of the world. And we have thousands of sites today which are on 4G because that's the technology which is being developed. And 4G, we do backhaul for 4G sites which are remote, which are not covered by terrestrial on our technology using, today most of the satellites use a GEO. We do use MEO to some extent, and we started using MEO from next year onwards more and more. The availability which we give today to telecom operators is 99.8, 99.9%, which is 4G. Now coming to 5G, which is getting deployed now, we have tested with AIS in Thailand, we tested in TIM in Brazil, we tested in few of the telecom operators. Our 5G POCs have been done. And using GEO, when you go to MEO and LEO, the latencies are lower, but using GEO, we have been able to demonstrate 400 Mbps download, 500 Mbps download capabilities to a Node B site, and which are working for a month and a half. And so the delays are taken care of. We have developed certain acceleration techniques in our modems. One of them is GTP acceleration and other few things which enable a user experience. When you are on a handset, you don't feel the delay. So those kind of techniques have been developed in our modems and in the technology, which enable a seamless and a user-friendly experience for a handheld device. So this has been proven, and we have been working with 5G operators also, and giving a 99.9% availability also.
Thank you.
Just want to add on this, all the operators like SES, Intel said, they have been happily using Satcom as a 5G backhauling, and it's complementary each other. So rather than facing a problem with what 5G wants, it's like we are working hand to hand.
I will answer your question from a LEO perspective because it was quite broad. From a virtualization perspective, the world is moving towards cloud-based software, processing in the cloud. software-defined radios locally working at the ground stations that are deployed remotely over the world, and doing a bit of post-processing in the cloud itself. So that's where the world is headed to. From our perspective, we have been software focused right from the beginning. We have our own software-defined radios which continue to evolve to support our customers. Coming to link reliability, it really, the number of nines really don't matter if the application that needs to be supported does not require it, right? For example, Earth observation does not require 6 levels of nines. It requires maybe 2 or 1 or even less. There are fail-safe mechanisms so we do not have to work under that constraint. What we have to work under is keeping up the availability of the service. Like if the antenna goes down, if the motor gets faulty, that has to be replaced. The SLA then becomes, okay, how soon can you replace the motor and get the antenna operational, right? But there are fail-safe mechanisms in that too. Like if the antenna goes down, you as a ground segment operator, you probably have 2 or more antennas in the same vicinity. So the satellite communication is handled or shifted to the other antenna in those instances. So that's second. On the max bit rate, that again is application specific. Like, you know, we can handle 1.2 gigs per second, but who's using it? Very few people. There are radios in the market, software defined, that can handle up to 4 gigs per second, 4 Gbps. But who's using it? Nobody. Well, I'm talking from the LEO, not from a broadband geo perspective, strictly.
Thank you.
So I'm Riaz Lamak from the Global VSAT Forum. Listening to the discussions, we see that, like Mr. John said, he has started manufacture and has given us a good track of how he has evolved. But that being said, there are many specialty products which is not viable to manufacture in India immediately. Maybe it will happen down the line. So to bridge the gap, what does these companies here have a plan in getting those specialty products available for India's growth?
Yeah, in fact, this is a very good question. We were all thinking about, actually we are on the process of thinking about these questions. Actually, not only specialty products, if you come to that, I can give you one very recent example. Space debris tracking radars, phased array radars, multi-object tracking phased array radars. As of now, if you see, yes, many components of this are being made in India. There are many industries who are making, but an end-to-end solution, combining all the hardwares, integrating the hardwares, everything together, power, all the things together, getting a good SNR, and also back-end software which process the data. Such a industry, actually nobody can now code for that now in India. So it is one of the important area where we have to collaborate with international organizations, international industries, get into them, discuss with them, get their design or whatever the things required. So such a working arrangement or the industrial collaboration is a necessity. Not only for space radar, many things like that. So that we have to start. I think whatever happening in India now is towards that goal. Even now to this conference also is towards that goal only. So that is the important. Anybody want to answer anything?
So Riaz, your question is like, you know, a good forecast which we have roadmap working on it. As Dhaka sir said and Mr. Anil said that space debris programs and all those things. The idea of what ISRO is planning is that let's involve international partners along with Indian system integrators, and we'll take those technologies which are not ready or yet to manufacture in India, but not in a full form, have something which is core. Let's take the core part and do a system integration in India. So on our side for a CPI, we are also thinking of setting up something jointly with existing manufacturer or maybe our own, where we would like to do something like 50% or 60% system which can be done here, and the main core which doesn't fit in terms of the volumes like feed. I cannot go immediately to manufacture something, do a R&D development here, but rest of the all other metals and everything we can import, do it here and then integrate it. Okay, that's the answer to your question.
Just to add, I think your question has three divisions in it.
Yeah.
Your question has three divisions in it, and these are the capabilities that needs to be considered. The three capabilities are infrastructure. What is the infrastructure available currently to do those specialty projects? The other part of the puzzle is regulatory. Is the regulatory conducive, depending upon the IP transfer and knowledge transfer and other such things, and what are the advantages and disadvantages on the regulatory side of things? The third most important point is the customer and the value of the market available. If you have to build a specialty equipment in India and it's going to be used by a few customers, then what is the point of developing that specialty equipment? And what are the opportunities that are available so that I can develop these specialty equipments in India and export it? So it's a puzzle, and all these puzzles needs to be answered so that there is an environment to proceed with knowledge and knowledge transfer. But I think any international company is happy to have a collaboration on these factors if there is these three parameters are available in the right format.
During the discussion, hello, ready? Yeah. This phased array antenna thing was discussed, So one of our lab, the DRDO, LRD, they have a roadmap that after 2025 will not import any phased array antenna or any beamforming technology, and whatever is required for creating radars using phased array antenna, this will be self-sufficient by 2025. But one question with respect to your, you come from Global VSAT Forum, so I'll put it a counter question to you. You know that VSAT Forum once made standard with respect to DVB-S2 and DVB-S2, SX and all that. But no two foreign OEM, their systems will not operate with each other. If it's a standard, why it is not adhered to as a standard?
Each of the OEM has its own proprietary, and Global VSAT Forum per se is a collection of all the OEMs, operators, system integrators, satellite manufacturers, launch companies. So our task is to galvanize and work together, and this probably each of the OEM would be in a better position to respond why and how it is. So it's not that throwing back the question, but it's beyond my
we need not
preview.
discuss those type of things here now.
I can answer it shortly. While RCS as a forum was discussed, debated a lot, and I think every OEM was part of it. But the way the technologies keep on changing. The problem is that it's like it's a 2-year, 3-year time frame of a technology, and suddenly 3 years something else happens. So one has to change RCS to something else. Like today we do operate S2X as a standard in one direction, but it is the other direction which is proprietary. While outbounds are generally S2X, which is adopted by most of the baseband manufacturers. But yes, in the reverse direction, everybody has his own way of how the capacity is to be handled. I think with the 3GPP coming into the 5G platform, you have LEO, MEO, and GEO satellites coming into hybrid networks. I think this thought is getting shaped more better now, and I do feel that something in this direction will happen in next 2 to 3 years.
Coincidentally, in the earlier panel also, this question was being discussed indirectly, and it was said that like a mobile phone can be used on any networks. We are also inching towards that on the satellite side, and that's my personal view, that should happen fast.
Yeah. So I would say that like there is now advent of like inter-satellite links and data relay satellite and big communication of satellites. So is this a threat to, let's say, ground station services where people could resort to, instead of using ground station, we go via satellite to a specific gateway? So is that a threat to both, let's say, the antenna manufacturer, electronic manufacturer, where you would have maybe reduced sales, and also to the ground station side of the service where they may be impacted by that?
Very good question, and very relevant as well. So currently, the restriction with ground station services is there's only so many regions in the world where you can deploy ground stations. So satellites in the low Earth orbit, they have to wait until they get over that region in order to communicate or send the data down, or for the satellite operator to communicate with their satellite. Now, inter-satellite links allows the satellite operator to pass that data through to different satellites in their constellation, which is over a certain region with ground station visibility, and get that data down, right? So I see that more as a complement, and allows the satellite operator to work with the ground operator, because ground station will always be required, because that data has to come down in some sort of fashion, right? Now, let's take the case of data relay. Currently, the technologies for data relay are only suitable to tasking, which is sending a command to the satellite, hey, now you're over, a region of interest, take an image when you get there. You send the task via, say, a satellite in GEO or higher orbit, and send it to the satellite. There's always costs associated with these, with these mechanisms. Inter-satellite links, for example, they are required to have onboard radios so that they can communicate with other satellites. There's an inherent cost to that. Of course, it comes with an advantage. With the data relay, there's additional cost because you have to add another payload or another card to your satellite to allow communication through a higher orbit satellite. So those costs and the ongoing service costs of using that data relay sometimes negate the advantage. But in short, right now the technology is such that ground stations will always be required. Now there are, looking into the near future, 4 or 5 years down the line, there are data relay networks that are coming up which will offer high bandwidth downlink. When such a data relay constellation is active and it has near continuous Earth coverage to be effective, that's good 6-7 years away. And the way for ground station providers forward would be to work with such data relay networks and provide them ground segment services, because guess what? The data relay services, the data relay constellation will need to backhaul all that data to a ground station as well.
Just to put in perspective, as long as there is satellites in the sky, there will be ground segments. So you can't write off the ground segment part of it. They are innovating. We are also innovating. They are coming up with new methods. We are also coming up with new methods, and we will be complementary to each other. So, and I think just to put an analogy here, it takes roughly an year to manufacture a satellite. It takes somewhere around 6 months to launch the satellite and get it to orbit, but it takes 5 or 6 years to operate the satellite in ground segment. So we have the maximum length of time that we keep these services running. So I think we are complementary, and we can't write off ground segment.
Yeah, in fact, if you see the challenges faced by the ground stations, actually the industries who are making the ground stations, as well as the space itself. See, now the lot of new operational objects. We are all discussing about the operational objects which has capability to transmit the data and everything. That is about 5,000 objects now. 3 years back it is only 1,000 objects, now it is 5,000 objects. Next 2030 it is going to surpass all the space debris objects. The 10,000s of operational objects orbiting around the Earth, especially low Earth orbit. And it is going to communicate. Whether it will communicate to ground stations or the space-based segments, we don't know. It will come slowly, it will come up. But still, this ground station is going to be here, and data reliability is paramount important, latency, everything will come there. So there are a lot of challenges faced by this. Then one thing is equal importance should be given for the ground stations. That is not happening. Mostly it is people know that if I send a satellite, I can hire something from other existing ground stations. Are we equipped with the growth in the operational objects, whatever they are in the LEO, GEO and MEO, or even D-space networks, D-space science missions? Are we equipped with this necessary augmented our ground stations for such getting into this type of business? That I am not sure. Anyway, it is as of now it is working fine. Later what will happen reliability wise or whatever there, that you have to take it into account. Okay, I think we are up to the time. I have one more agenda here, and I found one youngster from backside was raising the hand earlier, right? You are raising the hand. So last question you can ask.
Already answered, but last month there was an announcement in the US with T-Mobile and SpaceX, where they were talking about bringing satellite communication to the phones, right? And we're talking about very high frequency bands here, like, beyond Ka. And typically the ground stations have to be very large. Like what I mean by that is they're using beamforming. So how do you bring, wide area coverage of Satcom to cell phones with such a compact device? So like you were talking about focusing on ground stations, how do we bring our ground stations to become so compact?
Will answer.
Can I?
To space to mobile, but again the technology is in development, and a lot of companies are working on the infrastructure side of things, and I think the solution will be ready in another 2 to 3 years time, but I don't see that the maturity is there.
Yep, as I said, there are few companies who have announced such a collaboration of mobile to satellite space. There are few promising things which are happening. One of them is, you can call it HAPS, which is a high altitude platform, where it is kind of a airship which is up in the sky at up to 50 kilometers, and which can give some kind of a connectivity to a mobile. And well, the challenge is that, is it going to be a text service, or is it going to be a 5G, real 5G service? Because the kind of capability and the kind of processing which is required, there are challenges on the solar, on the power side of this such kind of a HAPS platform. There is a challenge on the life, it's 1 year, 6 months, and how do I change it back? And a mobile device, how does it play with the 5G terrestrial network and a BTS in the sky? So there are a few challenges which are still to be found out, but I think direction is that this is a desirable thing. I think it will happen. To start with, it will be a text service or kind of a voice service, but getting real 5G data to a mobile via a satellite directly is going to be a challenge for a few years.
Thank you so much. I'm just going to ask just a quick one more thing. So I'm actually with Fleet RF. We make satellite transceivers for autonomous platforms like drones and robotics. And so for us, like making the Satcom device as compact as possible is the goal. Now, what I'm also trying to understand in India right now is that when we talk about providing a Satcom service, to drone manufacturers or to any kind of marine robotics manufacturer or ground robotics manufacturers, there is also a market that is beyond the defense space. Like there is a commercial market in India that is, quite big, and it's only going to grow. So like right now, from a commercial point of view, Inmarsat is the only network that currently is available. Do you see other network providers becoming available in India, or how is that looking like for commercial Satcom, not defense?
If I understand the question, you're talking of commercial Satcom in India.
Yeah, like as in like if there are people or there are companies which want to use commercial Satcom service, what network options they have?
There are companies offering such services, like you had a panel earlier from Nelco who offers commercial satellite services. You have Hughes here who offer commercial satellite services. You have Airtel. And so they offer, then you have BSNL, which offers commercial satellite services.
So, I mean, these are all based on the Inmarsat network, right?
No, these are based on geo platforms today. As they move, they may be offering LEO and MEO also. So you have all the commercial Satcom services on every satellite is available in India.
Okay.
Okay, thank you. And we had an interesting discussion here, panel discussion here. And I am the Vice President for International Astronautical Federation, IAF, you may be knowing. I am Vice President, and Astronautical Federation present theme put forward by the President is sustainability, investment and security. So investment should go in hand in hand with the sustainability of the space and security of the space. So ground station is an important part of giving the security as well as sustainability, and it requires a lot of investments. Okay, thank you. Now my panelists have done a very good effort to answer to all of your questions. I would like to thank each one of you. Thank you. And now here in ISC 2022 Indian Space Congress, they have conducted one paper competition, and this is a paper contest they have conducted, and one Mr. Parthipan P, scientist from URO Satellite Center, ISRO, he got the first award, first prize for his paper, Novel Automation Algorithm to Maintain Frozen Orbit through Ground Track Maintenance Maneuvers. So I will invite Parthipan to give very brief presentation. Thank you.
Very good afternoon, everyone, and I'm very privileged and honored to be here. And first of all, congratulations to Anil Kumar sir for becoming the Vice President of IAF 2020. I mean, last month they have announced it. We were very happy. Congratulations, sir. And I would like to congratulate SIA-INDIA for organizing such a big event. So I'll straight into go into the my paper. I am Parthiban. I am from Flight Dynamics Group of UR Satellite Center. This is a bit more technical, so I'll try to, I have tried to put it as compact and as simplified version as possible. Yes, sir. So the topic suggested is a novel automation algorithm to maintain frozen orbit through ground track maintenance maneuver. So we will go step by step. First of all, what is ground track? So in this video, I have tried to simplify how a satellite, LEO satellite is orbiting around Earth, and similarly that is a 3D and this is a 2D illustration. From that you can see wherever the satellite goes, we derive a point called subsatellite point onto the ground, and then we draw the satellite's path. So that's called the ground track that we derive from the satellite's motion. So typically what happens for LEO satellite is, LEO satellites are affected by atmospheric drag, solar radiation pressure and everything. So the altitude reduces. Due to that, this track, it varies, it drifts. For example, if you want to image Delhi today, and if we don't maintain the track, it might not see the Delhi. It will be seeing some other place. So what we actually do is we perform maneuvers called ground track maintenance maneuvers to make sure the track is fixed for our convenience. That is one part. The second part is frozen orbit. Now, like in literature suggests, it is not a perfect sphere. Earth is not a perfect sphere, and our satellite motion is also not perfect. Like if you suggest it is a 1,000-kilometer orbit, it is not 1,000 kilometers. So in pole it can be 1,010. In equator it can be 1,006 or something, and in again South Pole it can be 990 kilometers. It is not perfectly 1,000 kilometer. Because of this, when I take an image, right? So let us say I'm having a camera and I have taken a picture of all of you today at this altitude. Tomorrow I'm taking you with 10 feet higher altitude, and day after tomorrow on underground 10 feet higher lower altitude. So this picture varies, isn't it? But we don't need this. For certain applications like interferometry, we need accurate altitude. It has to be maintained. We know that the Earth is not perfect, but what we can try to do is, we can try to maintain the altitude profile. For example, if I try to take the Delhi today, let's say my satellite is in 1,000 kilometer altitude and it sees Delhi 1,010 kilometer altitude. And tomorrow also it will see in 1,010 kilometer altitude, and day after tomorrow also. So I will fix the altitude with respect to the latitude. This is called frozen orbit. Usually this is achieved by critically inclined inclination. There is an inclination that is derived. But for all our low Earth orbit, we usually put in sun synchronous, special characteristic orbit. Therefore, the inclination is defined. In simple words, the satellite is moving around like this. You can see it goes around pole to pole. So the inclination is fixed. So there is an alternate solution for that. The alternate solution is, there are two orbital parameters called argument of perigee and eccentricity. If we could able to provide the appropriate combination of that, we could be able to achieve this altitude profile as constant. So this is the pretext of whatever the paper I am illustrating. Now, what we have done is, usually, as I said, this is how the ground track is. You can see the red line is the ground track, and then we usually, it is not exactly, it is not like exactly you have to maintain. We will have a margin. We will say, okay, if it is Delhi, within 500 meters of Delhi, you maintain the satellite track. If it is, if you have satellite which can go up to 1 kilometer or 2 kilometers, also fine, but that should be defined. Now this is the ground track, and if the altitude is reducing, the ground track tend to move away. Therefore, you have to do a maneuver to increase the altitude such that the ground track is maintained. Right? Now we have another constraint, that is to maintain the frozen orbit. For frozen orbit also you have to do a maneuver, which means you are going to spend fuel. So our illustration is to provide a novel automation algorithm. What it does is, it takes care of your frozen orbit just by doing the ground track maintenance maneuvers without any additional fuel requirement. That is in a nutshell whatever we have developed here. So I'll just go through the simple design philosophy. You don't even need to go and see this. So what it does is, it just takes the input from ISTRAC or wherever networks we have, and then it analyzes the data and see whether it maintains the ground track or not. If it doesn't maintain, it goes through the algorithm. Then the algorithm sees, for the given orbit, what is the eccentricity and argument of perigee that to be maintained in order to maintain the frozen orbit. Now comes the interesting part. So far there are no direct analytical solutions for this, but as the computational systems are advancing, we can do anything in numerical. We can dissect the epochs in milliseconds. I'm not talking about tens of milliseconds, even ones of millisecond we can dissect the epoch, and then we can obtain the orbit, because our orbital velocity is in kilometers per second. So we can I am operational in a certain latitude. I don't want my satellite to be touched. I don't want my satellite to be maneuvered at that point, because it will not be operational. Right? So that also we can incorporate into this algorithm, and we can say, you do the maneuver, whatever you want to do, you do it this particular point of time. Then the algorithm takes the epoch, dissects it, and then finds out the appropriate and exact epoch so that frozen orbit as well as the ground track is maintained without any additional fuel for frozen orbit. So that's in a nutshell I have summarized. I try to do my best. So these are the results. The first result illustrates the ground track, and then it is not very clear. It is for multiple ground tracks, like as I said, 500 meters, 1 kilometer, 2 kilometer. With the same ground track maintenance, what you are seeing is the frozen eccentricity. Means for the obtained orbit, I'll get one eccentricity. That eccentricity has to be maintained. You can see the sinusoidal wave, and it is actually in 10 power of -5. So the error margin is very less. Then another important parameter which I have told is argument of perigee, that has to be maintained as 90 degree in order to achieve our frozen orbit. So with this maneuvers, we could able to achieve both. if we cannot understand these three images, the final image illustrates everything. The final image is the altitude versus latitude plot. You can see that there is a single line you are seeing, right? Which means for any given altitude, any given latitude, the altitude profile remains same. So that's what we have achieved, and it has been developed by our in-house, and we are planning to incorporate in the upcoming satellites. And thank you for this wonderful opportunity. I thank you, the panelists. Thank you so much.
Thank you, Parthiban. Good work. Actually, as all of you may be knowing, we will be doing this orbit maintenance, orbit maneuvers often, very often, to make this ground track within the limits. And ISTRAC and URC both together doing it, maneuver design, checking whether any other operational objects or the debris objects are coming close or not. If you do after the maneuver, everything is being done. It's good thing, and like a lot of innovative things coming up. Very good. Thank you.
Thank you so much.
All the best. Congratulations.
Thank you, sir. Thank you. Thank you all.
So thank you all audience. Thank you panelists and all audience. Good, wonderful panel discussions. Thank you.
Now I would like to thank our chairperson and following speakers for active participation and their inputs in their sessions.